So let's understand how to sort an array using an algorithm called as bubble sort. It's easy to understand. So let's take a small array because the algorithm remains the same whether you talk about 5 elements or 50 elements. So we start with something small. So we create an array of 5 elements. So we have some numbers here. So 3, 2, 4, 5, 1. So we have some numbers, and this is the initial array. This is not in the sorted order, so we need to sort it. Now the algorithm is simple. We start at the very beginning here, and we want to compare two adjacent elements. We are going to swap these two because they are not in the correct order. Of course, we are talking about ascending order. So we are talking about taking this element and comparing with the next element and swapping them when they are not in the correct order. So this is going to be like this. Let's put it here. I say it's going to be 2. This is 3. Now we compare this 3 with 4. These two. Well, 3 and 4 are in the correct order. So no need to change it. And then we compare 4 with 5. Because we keep moving in this way. First we were here. Then we went to this. Then this. And now we are here. And if you compare this with the next one, they are not in the order. So we need to swap. So eventually it's going to be 1 and this is going to be 5. So at the end of the first round, you see the array arranged in this way. So you have the subsequent or adjacent elements compared. And whenever they are not in the right order, we are swapping them. So eventually what we did, we bubbled the largest of all the elements to the last element. That is the net result of the first pass, first iteration. So at the end of the first iteration, this is your array, and you already got the largest of all the numbers, push it to the last location. Done. Now for the second iteration, I don't have to consider this. So now we focus on only this part of it. This I don't need to consider. So start the process again. And 2 and 3, no need to swap. 3 and 4, no need to swap. So 2, 3, and then 3, 4, no need to swap. But 4, 1, yes, you need to swap. So 1 comes here, 4 goes there. So at the end of the second round, it's going to be like this. And of course, this 5 is already there. So in the second round, we did not consider the last element because we know we already got the required value there. And now we don't need to consider even this because 4 is the next largest value. So when we go to the third iteration, we don't need to consider even this. Now our array is only about these 3. So in the third round, I say 2, 3 need not be swapped, but 3 and 1 need to be swapped. So this is what we do. And then this is done. And in the next round, we are going for this. In the fourth round, now we are going to swap these two. So 1 and 2, and anyway you have 3, 4, 5 like this. So in each iteration, our goal is to take a part of the array and push the largest value in that part to the right corner. And if you keep doing it, eventually your array is sorted. So first time we consider all these elements from this to this. we don't need to consider this because this cannot be compared with the next element. So we go from this to this. Next time we take only these 3. We don't take all, we take only 3. And then we take only 2, then we take only 1. Like this, we keep reducing the area of focus. So this is called bubble sort. This is one of the sorting algorithms. So I repeat the process. First, we start with this. We go from first element and we go from here to this. This is our range. Every time we compare 2 adjacent elements, if they are not in the order, we swap them. Now, after we swap these 2, we get 2, 3. Now it is 3 and 4, no need to swap. And then we go to the next one. When you go to the next one, it's 4 and 5, no need to swap. But then it is 5 and 1, and we need to swap. So 1 comes here, 5 goes there. So this is what you get at the end of the first round or first iteration or pass, whatever you call it. So what is the net result of the first round? The largest of the entire array is pushed to the rightmost corner. So once this is done, the second round need not consider this. So we need to go only up to this. We need to go up to this, the third element, because that's the last element we can compare with the next element. So after this second round, again, if you apply the same algorithm, like comparing 2 adjacent elements and swapping whenever they are not in the order, 2, 3 need not be swapped. 3, 4 is also fine, but 4, 1, they are not fine. So we bring 1 here, we take 4 there. So at the end of the second round, you got the second largest value pushed to right corner. Every time we consider only a part of the array. So right now, if you take the third iteration, I'm not going to consider these 2 numbers because these 2 are already in the order. So our comparison is only confined to this part. So in the third round, again, we are comparing these 2. They are in the same order, but these 2 are not in the same order. So swap them. So at the end of the third round, you get this. So you keep going, you keep doing this, and eventually you're going to sort the whole array. Well, there is a slight optimization technique in bubble sort where in some cases your array is sorted before you reach the last round. Maybe after the second round itself, the array is sorted. Then you can stop there without having to go to end of the whole process. But that's optimization. That's slightly advanced technique, not really complex, but it's a technique you can apply to optimize your algorithm. But let's talk about the basic algorithm and see how we implement that in C language. So here is the program. I want to create an array of 10 elements, and I'm trying to use a slightly new technique to create array. I don't put the size directly. I don't hard code the number. I create a constant using what is called as hash define. This is called a constant. We are creating a constant and it represents value 10. When you write code that is easy to maintain, we do things like this. So we create an array of size elements. I can easily change it to 20 or 50. The whole program is now working with the new size. So it's a much better way to write code and strongly recommended practice. So define a constant. This is the name of the constant, typically put in uppercase. And this is the value we want the constant to represent. Now, come here, create an array, create some variables, then initialize the random seed, and this is your original array. Again, see, I less than size. Size is 10. I less than size is going to take up to 9. 0 to 9. Perfect. So we initialize our array and also we print it. This is our original array. Once the original array is printed, now our bubble sort process begins. This is where we use bubble sort. So what are we doing? If you have an array of 10 elements, you need to have 9 iterations. So this is where you are talking about 0 to size minus 1. That means for an array of 10 elements, you need only 9 rounds. You need to have n minus 1 rounds. So here I'm saying size minus 1 because we are starting from 0. Well, you can start from 1 if you like, because this is not actually referring to index. This is referring to the number of iterations. So whether it is first iteration, second, third, and so on. So I go from 0 to size minus 1 actually. Size minus 1 gives me 9, and then I less than that means we go from 0 to 8. So we are talking about only 9 iterations. This loop is repeated for 9 times. Okay, what do we do then? Every time we go from 0 to size minus 1 minus I. So we need to go up to last but one element. We don't have to go up to last element. So this is going to give me size minus 1. So 10 minus 1 is 9 minus 0 is 9. So we go up to 8th element. Because the algorithm is to compare every element with the next element. So we need to stop at last but one element always. So in the beginning, I is 0. So we start by checking whether jth element is bigger than j plus 1. This indicates the elements are not in the order. If jth element is greater than j plus 1, as we have seen, if this is bigger than that, we need to swap them. That's what I'm doing. I'm swapping them. So using that simple swapping technique, we swap a of j with a of j plus 1. Once they are swapped, we continue. And then we check the next element with its adjacent element. And so on, we keep on doing this. We keep on checking and keep on swapping. And once this inner loop is done, then you can say the largest of this array is pushed to the last element. It is. So next time, we don't need to consider that. We don't have to consider the last element. So we will go only from this to this. Only this portion is considered. This is not considered. So to do that, what we do is we are going to say again, this I is incremented every time. So this time size minus 1 minus I. That means we are talking about something like size minus 1 is 9, 9 minus 1 is 8. We go up to only 7th element, 7th index, right? That means we go up to 8th element physically, and it is compared with 9th because the 10th element is already in the order. We can change the same thing slightly. I can say this is 1 and I can remove this minus 1. I can just put simply I. And here this can be done. We can put it in this. You can go from 1 to I less than size. Because what matters here is how many times this inner loop is repeated. The inner loop is repeated for 9 times for an array of size 10. Now, after all this process, and after repeating this process for these many times, if you go and print, you should see the array in sorted order. Let's go build it and then run it. And you are seeing the original array. This is the original array, and this is the sorted array. You can see all elements are sorted. If you want, you can see how exactly the sorting process is taking place by printing the array at the end of each and every round. It's possible to display the array at the end of each and every round so that you understand how the array is actually being modified to sort the elements. Now, just to understand that, you can put this inside this. So this whole thing I'm going to put here. And I'm going to say this is not the sorted array, but this is after a particular round. After round percentage D. And that is going to be I. After ith round, first round, second round, and so on. And this is where I'm displaying it. But be careful, you should not use I then. You should use some other variable, otherwise you will be disturbing I. That's going to jeopardize the whole thing. So this is where you can print, and you're going to print after each and every round the whole array so that you understand how the sorting process is taking place. So this is how we do that, and we need to declare one more variable, that is K. Let's build it. And then this is the original array. And after each round is completed, we want to print that. And we want to print the entire array. Let's go run it. So there you see, after this first round, this is the original array. After the first round, the largest of that is 99. It is here. And then the next largest is 85. And then 82. Then 81. Do you see how it is working? Then after round 5, this is what we have. And then like this, it keeps on doing it. And after 9th round, because I told you for an array of 10 elements, we need to have only 9 rounds. And after the 9th round, your array is completely in the order. But if you see, it is pushing the largest element to the right corner, next largest, next largest. This is how the algorithm works. So you can display intermediate results to get better idea about how the algorithm is working. So this is called bubble sort, and this is the algorithm, and this is how your inner loop is constructed, and this is the outer loop. Sometimes what happens is your array is sorted much before the last round. I think you can see that somewhere here. Look at this. The array is sorted after round 4. That's it, right? The array is sorted after round 4 because in round 5, you don't have to swap anything. In round 4, you had to swap because this 42 and 40. But then you don't have to swap anything because everything is already in the right order. So there you can see everything is already in the order. I don't have to swap anything. But I still ran it multiple times. You see here, I ran this, all these are unnecessary. So starting from here, starting from 5th round, I don't have anything to swap. So there is no point in continuing beyond 5th round. So you can optimize it. You can enhance this algorithm slightly in such a way. If you don't swap any elements in a particular round, if you don't swap, it means the array is already sorted. There is no need to continue any further. We can stop there. So if no swapping is done, then you can stop your process, you can stop your rounds, and you can conclude the array is sorted. Now let me create a second version of it. This is bubble sort v2, which is basically enhanced version. So I create a variable and I say swap is initially 0, means false. And this is actually set to 0 before we get into inner loop. So I say swap is equal to 0. And in case if you swap, then we set it to 1. 0 is false, 1 means true. Now after we come out of this, we want to know whether we swapped. If not swapped, that means if you did not swap any element, there is no need to continue. You can break. Break what? The outer loop. You're going to break the outer loop because there is no point in continuing because the array is already in the sorted order. Look at that. It's already in the order. So when it is in the order, there is no need to continue with all these iterations because it's waste of time. So we can optimize our algorithm by using a flag called swap. So let's go and try this. Build again. This is the new version and run. And you see this. After round 6, it stopped. It didn't go to round 9. After round 6, we realized we don't have to continue anymore. So you saved 3 rounds, 7, 8, 9. So you can optimize your algorithm by adding a little more. And even in interviews, they would ask you. They would ask you to write a program, and then they would ask you whether you can improve the program. So generally, you better write the first version first, and then when the interviewer is asking you, can you improve this algorithm, then you bring this swapped flag into picture. That's going to be a better order. Because if you go with the best algorithm in the very beginning, and if interviewer says, can you improve it, you will be in trouble because you don't know what else you can do to improve. But if you can start with the normal version, not optimized version, when you're asked to improve, you can improve. So this is our version. And this time it is going all the way because the way the data is, it is going to run all the way up to 9th iteration. Keep running a few times, you will see that. This is what it is. So hope you understood the algorithm. The algorithm is saying every time compare 2 adjacent values. If they are not in the order, swap them. And this process begins here and it goes up to last but 1 because last but 1 is compared with the next one. This is where you have to stop. The net result of that is going to be pushing the largest of all the elements to the rightmost. After first round, that's what you achieve. After second round, you achieve this, the second largest, and so on. So this is an algorithm called bubble sort.